Hello guys, welcome to Ibu UX. I hope you guys are doing well and doing great. In today's live, we are going to see about a different topic, which is totally different from our entire channel. But somehow back in days, I have also uploaded videos related to this. Now we are going to take the topic once again into the platform, into our channel. Okay. So what's it all about? This video is about my special project which I was done in back in days a few years ago in 2022 during my college days. These projects take me to an hackathon where I went to the grand finalist position. But during that event, along with four teams have competed with us, totally five teams competed in this topic, in this particular topic, but none of them got the prize or none of them got the results the judge expected. So which is mainly the accuracy. So now what I'm going to do is that I'm going to dust it out and taking the file. Now I'm going to start it over again. I don't want to give up this project because at the time I have a mission and vision of this for this project to make this project to a product level. So right now I'm going to make it once again. But why I'm making this live video is that this live is going to be an experience sharing, a knowledge sharing while I am doing such things along while I'm developing such or else while I'm doing R&D, research and development for this project. I'm going to share my knowledge and I'm going to share my experience with people's, and also this video is going to be a documentary for that entire project and entire process. So I hope you guys have the backstory about this, but this is not an entire backstory. This is just a few lines of that backstory. Now I'm going to deeply explain about that project, what we have done, and what happened, and what we need, and what we are going to build. So we are going to find answers for these questions in this live. I'm going to share my screen so that you guys will easily understand what I have done, and I'm going to show the things what we have done past in days. So back in days, what we have done is that we have developed a device which is useful for the people to calculate their glucose. We all know that measuring the glucose level is done in an invasive method. Invasive method means, for example, let me say that what we have done is that patients who have a diabetes will go or else will take an checkup for the glucose, how much they have. So for this, the traditional way is called as invasive method. So in this method, the patient needs to provide a blood sample to a machine which calculates the glucose level for them. Like for example, they need to prick their finger. In one of the fingers, they need to prick that finger and a drop of blood comes out. The device captures the blood and it going to provide the glucose level. This is called an invasive method. But the solution we have provided for this invasive method, first we need to analyze what are the problems in the invasive method. Let me show you. Sorry. So this is going to be the simplest method. That's why I'm sure just search and I'm going to show you people what is an invasive method. So this is the invasive method. Invasive glucose monitoring methods involve pressing. This is what I have said as pricking. Pressing the skin to access the blood or interstitial fluid for direct measurement. So here, this is the technical definition for it. Next, how it works: the lashon pricks the finger to get the drop of capillary blood, which is then placed on a chemically treated test strip read by the glucometer. This is an invasive method. So it has some risk and it has some side effects too. I'm going to show you that. Disadvantages of invasive methods in glucose monitoring. So you can see, so while we are doing glucose monitoring in the invasive method, we have some certain risk, like we have pain, risk of infection, potential tissue damage, inconvenience of using sharp objects, inability to capture continuous trends. So this is one of the disadvantages of using or else pricking the blood method, invasive method. So let me show you the image how it works. This is a type of it. So what will then? The user will pierce the skin of a fingertip and they will eventually provide the drop to an strip which has that electrode plates that is going to calculate the sugar level. So this has pain, risk of infection, potential tissue damage. Apart from this, we have to capture the continuous trends of these. If you have a diabetes and you need to calculate for a prolonged amount of time, this will become an annoying one. For example, let us consider the one of a person have this diabetes, and that person needs to monitor his glucose level for an simultaneous period of time. For example, let me say he's going to take a major surgery. First, doctor will say he or she needs to reduce the diabetes. So for the several months, 1, 2, 3, 4, 5, 6 months, or some kind of months, they need to undergo the glucose monitoring. So they need, because they need to reduce the glucose level for the major surgery in upcoming days. So they need to monitor the glucose level. So each and every month, or else each and every day, they need to, or else each and every week, they need to prick the blood, pierce the skin, and they need to take the samples to calculate the glucose. This is the disadvantages, or else the backstages, or else backdrops of using invasive method. So for this disadvantages or else backdrops, we have suggested some solution or suggested some methods which is called as non-invasive glucose monitoring. If you guys don't know about that, you can also check out my video which is present in the YouTube channel. You can check out that too, which is uploaded back in days in the 2022. You can check out that link more about that. The non-invasive glucose monitoring, where we have used some sensors and a controller unit to measure the glucose level for a person. So whatever the things happen in this world, even the glucose monitoring by using these kinds of invasive method is also not an accurate one, because of in our body biological measurement or else monitoring is an inaccurate one. If you place a fingertip and you have calculated glucose monitoring and simultaneously you have taken the another sample from another fingertip, those two results will vary. So even with the biometric, all the biometric monitoring is not an accurate value. This is just an assumption value or else a near accurate value. it is not an exact accurate values. So this kind of invasive method itself has a plus or minus values between the fingers or else while we are calculating. So since this have, we are going to provide a solution for this one. Even the exact percentage will have a variance. We are going to provide a solution for this too. It will also have a variance. That's what we got. While calculating with a non-invasive method using some sensors, controllers, and we provide some samples and we're going to calculate and provide the output which has plus or minus variance. This is totally an inaccurate one. So here we need to calculate both the things. So we need to take two samples. Like first we need to take the sample with an invasive method, we've gotten value, and we need to take then another sample with a non-invasive method and we are going to compare it. So here what happened in our solution with the non-invasive method is that we got plus or minus variance comparing to invasive method in a higher range. So this is what happens in the hackathon back in days in the 2022. While the 5 teams competing in this problem, none of the team didn't get the exact results, exact accuracy, which is correlevant to the invasive method. So this entire project was shut down after that. Now I'm going to take it over. At the time, we have artificial intelligence AI to help us or else to improve or else to make R&D, but it is not effective as of today. So here what I'm going to do in upcoming days, I'm going to continuously upload or else continuously going to document about this entire R&D process. What I'm going to do, I'm going to take artificial intelligence to help along with me in this process. And I'm going to once again refurnish this entire process and I'm going to make this into an relatable product. That's what I'm going to do. So for this previously I have done with some of the things. Now what I'm going to do, I'm going to use Gemini for this purpose. Great shout out to the Geo for providing wonderful plan. This is not a promotion or else anything. This is just a shout out because of I have recharged my Geo SIM for a certain amount where they provided some offers. Along with that offer, they have provided the Gemini Pro models to test out with for the students and the creators. This is really useful because you can do much more things with this. Really shout out to the Geo for providing such an offer combined with the Google Gemini. So here I have my Gemini Pro plan, and what I have done here, I have done several R&D, and one of the R&D here I have done for this project. Back in days, I have the entire documentary of this project and what I have done and what are the tweaks I need to do. In this, I'm going to take this Gemini Pro model as an companion for me for this entire project and along with an R&D process. So let me explain my previous project's topics and how it works and how I have done. Let me show you how we have done is that okay. Better I should let me run this. Okay, what I need to do. Okay, here first let me show you from the real slides itself. Let me stop the audio. Okay. Oh, I hope you guys can hear my voice. I don't know about that. Let me check it. Yeah. Okay. Small India Hackathon 2022. At the time, typically first we need to analyze what is diabetes. Typical way of blood sugar measurement is collect a drop of blood. This is as I have introduced this point in the initial of this live itself. Current available glucometers which can be used by patient at the home, invasive, non-invasive method. These are all the things we got. Next, okay, 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 guys. This is what I have looking for. Yeah, spectroscopy and machine learning. This is the solution we have provided back in this. So spectroscopy is nothing but using some sensors, spectroscopy method using some light emitting diodes to calculate the sugar level as a sensor thing. And this diabetes is measured in two, or else it is categorized into two things: diabetes 1 and diabetes 2. According to the category, we need to provide some different solution for that. But a common solution for this entire topic is enough, more than enough, I think so. Instead of going for the different types of diabetes 1 and diabetes 2. So here, the main point we need to understand here is that we have used an NIR, which is nothing but near infrared radiation, is considered to be a method for non-invasive blood glucose testing. The present study evaluating the long-term accuracy and stability of the method. A non-invasive method does not invade the human body or based on various methods, including spectrometry and analyzing the other parameters correlating with the glucose level. So here the dangerous part comes in, which is nothing but diabetics risk. Diabetics can conclude at the 45.8% into a cardiovascular risk. So that's why we need a serious concentration on this disease. So since I have told you there are different two types, type 1 and type 2. The third type is gestational types, and this is not a, this type of is usually resolves itself by after pregnancy. This is for the certain cases only. And the next, so we need to know which is normal and which is abnormal for the diabetes. Normally, 80 to the 120 is considered to be the normal one. If the sugar level drops below the 80, it is considered to be low blood sugar, or if it exceeds the 120 mg per dl, it is going to be the high blood sugar. So in between the 80 and 120 is considered to be the normal one. So here I have also mentioned how our solution works in a technical manner. When a light ray passes through a biological tissue, let me draw this one in my paint software. Okay. So I hope you have understand the invasive method. Now I'm going to show the non-invasive method of using NIR sensor-based calculation. So here I'm going to draw something. Sorry. Okay. So imagine you have a layer of skin. Inside this layer of skin, we all know that blood is flowing, and each and every blood consists of an what? Blood vessels. Inside the blood vessels, we have the blood cells which is flowing in a constant manner, constant rate. So in this method, we are going to calculate the blood sugar value. In other terms, we can easily say what is a blood sugar is nothing but it is some kind of fatty substance which is stick to the blood cells. This is going to stick to this just like a fatty substance. This is not going to entirely stick with all the blood cells. It is stick with a certain amount of blood cells. So this is like this. This amount of fatty substance is varied with the glucose level. Or in other terms, this is how we are going to calculate the glucose level. Or this is how we are going to measure the glucose substance. If this molecular fatty substance is higher in the blood cells, then it is concluded with a higher blood sugar value. Or else, if the substance is lower in manner, this is going to be measured as a lower blood sugar value. This is how it is calculated. Let's get into a deep manner. As of the technical thing we have mentioned in our PPT, you can see when a light ray passes through a biological tissue, it is both observed and scattered by the tissue. Light scattered occurs in biological tissue due to the mismatch between the refraction index of the extracellular fluid and the membrane of the cells. Variation in glucose level is that affects the intensity of light and scattered from the tissue. Bead-Lambert law plays a role here. Major role is observance. Measurement which states the observation of light through the any solution is the proportion with the concentration of the solution and the length path traveled by the light. First, I will explain the first paragraph what it says in a technical manner by this drawing. So here we are going to pass the light rays. These light rays will pass the tissues. Here, some of the light will reflect. Am I right? Some of them will reflect. Some of them is passed. So here, just imagine this is just a LED light source, which is reflected on a skin surface. We can imagine is this as a fingertip. So in the fingertip, we are going to pass a light. Here it is called as NIR, near infrared, which is nothing but the light emitting diode, LED, is used to pass this light. So once this light is passed inside the skin and it penetrates, some of the light rays will penetrate. As we all know that if light is passed on a hot subject, it will scattered. Or else if the light is passed on a polished surface, it will reflect some amount of thing. So likewise here, some of the light rays is passed inside through the tissue and some of the light will be scattered outside. So in this condition, some of the light is passed inside the tissue and eventually reaches the blood cells. Inside this blood cell, since each and every blood cells has some fatty substances, it is called as a glucose. If the light ray is passed to these blood vessels, it will eventually penetrate the blood cells. In some conditions, these rays will eventually drop on the blood cells which has the glucose substance stick to it. In other terms, it is a glucose. So what will happen? It will scatter there too. So which will eventually lose the light rays intensity. So in other terms, we can say these light rays will eventually, what will happen? Lose its intensity to pass. If it touches the glucose value which is stick to the blood vessels or blood cells, it will eventually, what will happen? It loses the intensity. So it will refract once again back to the opposite side, or some conditions it will penetrate to this. This happens continuously according to the glucose substance thickness. If it has a glucose level in a higher manner, the large amount of rays will be observed and the less amount of light will be refracted. But if the glucose level is lower in condition, a huge amount of light rays will be passed, and also a higher manner of the light rays will be refracted in this condition. So if the light rays, the output of the light rays refracted is depends on the glucose molecules present in the blood cells, So if the higher glucose substance is present stick to the blood cells, we have lower intensity of the light refracted bound out of the skin. Or else if we have the if we have the higher amount of blood glucose less, the lower the amount of the light rays will be refracted. If we have the lower amount of glucose level stick to the blood cells, we have higher amount of the light rays passed outside, which is, in other terms, it is inversely proportional here. This is what this second paragraph says. So in the technical part, it is the B-Lambert law plays a major role in absorbance measurement, which states that the absorbance of light through any solution is proportional with the concentration of the solution and length wave traveled by the light ray. This is nothing but the inversely proportional one is says in a technical manner by the B-Lambert law. Further, we need to calculate this thing because of how we are going to calculate. Since the light ray passed have some certain wavelength and certain power, certain voltage. Let us say this light ray which is passed outside the skin tissue is in the 5 voltage. And we can say this takes under the some certain wavelength. So these wavelength are necessary and we need to calculate these two. Because of this says the intensity of the light we have going to use. Since we have different intensity of light, here we are going to use 940 nanometer. 940 wavelength or nanometer of light going to be directed from the skin tissue. So this is going to be passed, and once again we are going to get the light source which is refracted and also rebounded due to the glucose molecules present inside the blood cells. Eventually it will reduce the nanometer or wavelength of the lights. Some short we can say some lesser than 940 nanometer. We are going to calculate this and we are going to produce this is the glucose level according to this wavelength and according to the refracted lights. This is how the non-invasive method. And keep in mind, we have several methods in non-invasive glucose monitoring. This NIR, near infrared calculation spectroscopy, is one of the method. We have saliva, we have sweat-based calculation, and we have breath-based calculations. These are all several other non-invasive methods for calculating the glucose level. So one of the method we are trying in this non-invasive method is by using the near infrared or some light emitting diodes. So this is the basic principle that happens while we are calculating with a non-invasive method or by using the near infrared NIR. This has some several drawbacks, which is I have said in earlier stages of this live, is accuracy. We don't reach the accuracy we have waited for. So now I have made an R&D by using the Gemini, and I have uploaded my previous documents for this, and I have also taken some latest papers from the Google Scholar. I hope you people know the Google Scholar, which is a good resources for the papers citations thing. Here you can search for the citations. This is a Google Scholar. So in this Google Scholar, the technical papers can be read, or else if you want the technical citations, taken documentations, you can grab here from this Google Scholar. While taking these citations or papers, you need to be aware if you're working with a project, you need to take the latest papers. Here, I have short by the date because of for me, I need the latest technology which was used for this problem statement. So what I have done, I have provided the custom range from back of 4 years or else relevant to the 3 years. So I have mentioned 2022 to the 2026. What are the papers have we got? Okay, and short by the 2026 and below that. So from this citation from this Google Scholar, almost surfing to the 6 paginations, I have shorted out 4 documents relevant to my NRI topic in the non-invasive glucose monitoring. So while doing this, I have taken some 4 documentations relevant to the NRI. You need to keep in mind relevant to my NRI spectroscopy or else improving my light emitting diodes, fabricating the sensors, fabricating the controller, fabricating the method I am going to use. So relevant to that, I have filtered out some documentation and filtered out 4 documentation for this. These are the 4 things I have taken. I will show you one by one. So first thing, GluFi prototype and non-invasive glucose measurement. This is an abstract. I will show you some other thing. Machine learning maximizing. Okay. So each and every topics is differ from another. Like for example, let me say, so in these 4 documentations I have, each and everything is differ inside that one by one because of already I know artificial intelligence and machine learnings have improving our lives. We all know that. So why can't I use those technologies inside my non-invasive glucometer? That's why what I have done is that I have stick to my sensor near infrared technology, spectroscopy technology, and combined with some latest sensor fabricated or latest fabricated equipments along with this NIR spectroscopy. And also, I have combined ML artificial intelligence for this to enhance accuracy. This is what these 4 different documents represents. One of a document represents the fabrication of a sensor which is eventually used particularly for the glucose monitoring and enhance accuracy. And one another document represents the model or else artificial intelligence we are going to use for the boosting of accuracy. So one another document represents maximizing the glucose detection accuracy by the fabricated sensors in another manner. And the next generation polarimetric biosensor machine learning, which will be helpful for us to maximize the output we got from the fabricated sensor as well as the machine learning or else artificial intelligence. So these 4 distinguished PDFs or else documents provides a different topics to be worked in different manners. One of thing I have opened, maximizing glucose detection accuracy with sensor based optimized deep learning algorithm. Here you need to understand maximize the glucose detection accuracy with sensors. This one of a different topic inside the non-invasive glucometer, it can which is inside my NRI spectroscopy and sensor based calculation itself. So instead of going through all these technical things, let me show let me clarify you peoples what they have done, and I will shortly mention it in some few words. And these documentations are taken from the global wide, from the different peoples. Shout out to these peoples. I don't want to misuse their misuse these papers. Just what I'm going to do is that just I'm going to get some knowledge from their papers. Okay, here what they have done, really they have improved a deep learning algorithm for the sensors to get an accuracy that is clinically proven for the calculation of glucose monitoring. Since we all know that at the starting of the live itself, I have told you peoples that even with the invasive method, which is an inaccurate one, it's not an exact one, it has some clinical approvals. So these that invasive methods which we calculated from the different fingers, it also have proven by the medical industries. So we have that certification for that. So likewise, if I'm going to develop a product for this glucose monitoring, surely my non-invasive method needs to be inside that criteria too, which is nothing but clinically a proven one, or else it needs to meet the medical standards of accuracy. So here the most important thing in this monitoring is the best of this accuracy. So to improve the accuracy, we are going to make an deep learning model for the sensor-based calculation to provide the best of accuracy. This citation provides an algorithm or else an learning algorithm to be implemented to my project to get the best of the accuracy. And I'm going to provide open the next one. Sorry, this is abstract. So the machine learning enhanced non-invasive glucose monitoring via compact matrix CSRR resonator sensor. So here they have I think they have entirely fabricated a new sensor for this. Let me show you how it looks like. This is a which is nothing but what here they have done. They have done a chemical engineering here where they combine two chemical plates to make a new one, which is helpful as a sensing unit for the measurement of glucose monitoring. I will show you. This is an entire paragraph, lot of paragraphs. So if I take, it will take a long amount of time to explain. But don't need to worry about that. All these four documents has been summarized, and best of the output can be produced by our Gemini model. This is why I have taken the companion, AS and companion, because of which is going to provide a best solution for us from these PDFs to combine with to make a new product. So that's why I call this an R&D, research and development we are going to do. Here also what they have done, they have created the new chemical equipment by combining two different plates. Okay, these are the four documents which I gathered from the Google Scholar from the latest dates. Okay, so I have prompted this and I have got this one. What they have provided this. Here Lily in previous methodologies I have used the NIR. I have stick to that, and I need to change or stick some sensing units over there to provide the best of the output. Here what they have said here, with the four documents I have provided as an prompt input. Upgrade your plan using this. In fact, these four papers covers the three most crucial parts of your device: the processor, the sensor, the brain. Okay, let us categorize these things. So first one, the processor, sensor, the hardware foundation. In the previous one, we have used near infrared spectroscopy or near infrared radiation for the ray for calculating the, or else it acts as a sensing part for the glucose monitor. In GluFi prototype, in this document like GluFi, in this document, what they have given is that they have used ESP32 as their controller, microcontroller. So let me first, let's go with the sensor innovations itself. Yeah, here. For the sensor, not in that GluFi, it is mentioned in the next generation polarimetric biosensors machine learning, that CSRR. What they have? Yeah. In that paper, what they have used a different sensor, even though they have fabricated the new sensor for that too. In our NIR, we have the biggest flaw, which is specificity. Standard NIR confused by water and skin thickness. This paper uses polarimetry. Glucose is chiral molecule, meaning it rotates the polarization of the light. Water and skin do not rotate light in the same way. Yeah. Glucose is chiral molecule, meaning it rotates the polarization of light. Standard NIR confused by water and skin thickness. So previously I have drawn a skin and blood cells and the glucose substance that stick to it. So here what they are trying to say is that with that methodology, our body consists of 70% of the water, and also for the different color people we have the different thickness. So if the skin thickness varies, according to that, we are passing some rays, NIR rays above the skin, which most amount of the skin light will be refracted according to the skin thickness and the water level of that person. So in this paper, they have provided the polarimetry also. Glucose is a chiral molecule. Chiral molecule, meaning, and let's first we need to understand what is a chiral molecule. I think chiral molecule means the oval shape or a round shape. If the light rays is passed, chiral molecule meaning that non-super what's superimposable on its mirror image, much like your left and right hands. They are minor images but can be perfectly aligned. Chiral blood, a molecule that exists in two mirror image forms known as enantiomers, which are not superimposable on each other, much likely left and right hand. The biomolecular environment of the body, including blood, is highly selective. Selective? Highly? Highly selective and will interact with each other enantiomer differentially, leading to potentially distinct biological effects. Okay. Okay. Like this. Yeah, understand. Okay, I think I got the point here. So you can see the chiral molecule means for the different structure of our hands, we have left and right hand. According to that, we have molecules aligned to that blood cells. This is what they have proposed in that paper too. So chiral molecule, meaning it rotates the polarization of the light. Water and skin do not rotate light in the same way. Okay, let's compare. If we pass the light rays for the right hand, it will eventually, what will happen? It will eventually rotates the polarization of the light. So this entirely varies for the left hand because of those two molecules are chiral molecules, each other facing left and right hands. That's what they proposed here. So do not rotate in the same way. So if the light is passed in the right hand, the chiral molecule will rotate in a different manner if you compare to the left hand because of they are both in a different directions and different manners. That's why they have said here as a chiral molecule. So since light is an energy which will has an effect to rotate that blood cells, I thought so. This is what here they have mentioned, meaning it rotates the polarization of the light. Water and skin do not rotate the light in the same way. Exactly what they have. So since we have mentioned in the previous previous thing that when it refracts, it is going to polarize and rotate the molecule. Eventually, it ends up refracting that light in a different angle. Okay, I understand this point. Next, key upgrade for you. New method. Instead of just measuring how much light gets through intensity, which we have previously said in that paint software in a paint, measure how much light angle rotated, polarization happened. Okay, I understand. Instead of getting the light intensity, here they are calculating the polarization, how much angle the light is deviated. I understand this is a new philosophy here. This is an entirely new philosophy comparing from the previous methodology. Implementation note. The paper uses a special material GESE. This is what they have said here. GSE inside this paper. First, we need to find out what is the GESE. I have read this paper, but not so much. Is this paper? I've taken the correct paper or else. Okay. Semiconductor photo detector principles. Photo GESE. Something looks like okay. GESE flake. First principle analysis of GESE. First, we need to find out what the GESE means. Okay. Germanium selenide. Among those materials, germanium selenide. Okay. This is what the germanium selenide is, a chemical material they have used as a sensing part. Let's see. There are other germanium selenide. See at the bottom. Okay. You can see flexible germanium selenide nanometric sensor. Wow, looks good. So you can see the sensor part become a thin film. Whether this copper-like structure, it is not a copper, just for referencing, I am saying there's a copper-like plate. You can see this is what they have used as a germanium selenide nanometric sensor. This is a nanometric. They have entirely structured into a nano particles, nano plates. This is the exact phrase we need to say here. Nano plates, where these plates are made of germanium selenide. This is entirely fabricated sensing part. This is entirely fabricated. They have developed their own part. Okay. Germanium selenide, which might be hard for you to buy. Yes, work around. You can mimic this using standard components. Place a linear polarizer seat in front of your LED. Linear polarizer sheet. Okay. Let's search for. Okay, understand. Just cost around 120 rupees for us. First, we need to see linear polarizer sheet. Okay, such kind of this sheet looks like which is used in the movie industry or else in the photographic industry. I think so. This is what it looks like for mirror. Oh, okay, this kind. It looks like it is used in the lens, photographic lens. I think so. Okay, understand. This is what they are trying to say. Linear polarizer sheet in front of your LED, light emitting diode, and a second polarizer sheet rotated 90-degree in front of your photodiode. Okay. Place a linear polarizer sheet in front of your LED and a second polarizer sheet rotated 90-degree in front of your photodiode. Okay. So here LED is referencing our transmitting source of light. Okay. So that light is going to be passed to a linear polarizer sheet. Next, a second polarizer sheet rotated 90 degrees. How I can need to imagine? Let's draw this in the paint software itself. Just a raw image. Just a raw image. We are going to draw this one. Okay, consider. Consider this is going to be our LED transmitter. LED. Okay. Next, we have the thin polarizer sheet. We got this thin polarizer sheet. Okay, that's what they have said. Next, sorry, next, that's what it says. Okay. Next, what is second polarization sheet rotated 90 degrees in front of your photodiode. Why are they saying? Okay, I understand. Okay, I understand. Okay, I understand this. If we rotate this 90 degree, if we rotate the same sheet, if we rotate the same sheet in a 90 degree, which looks like a diamond shape in the top view. Diamond shape, am I right? You can see now you can grab a point. If we did diamond like shape, this rays will be passed in a focused manner. Understand now? I understand now. This is the same thing sheet. After the sheet, once again we are going to place the photodiode here. Understand here, photodiode. So in between, we are going to place our sample, which is nothing but finger. Light rays eventually pass this photo sheet, sorry, polarization sheet. Once again, the emitted or else polarized lights eventually reach these polarized sheets, which going to act as a focus point, focal point, and will focus the remaining light rays in the photodiode. Now I understand the sayings. Okay, the amount of light that leaks through the tells you the glucose level. Super, I understand the process. Next, once again, once these light rays are passed, okay, once these light rays are passed, we need these analog waves. Because of each and every sensor produce an analog waves as an output, we need to convert as a digital data. So for this digital data, what we are going to use? We are going to use a microcontroller. In previous methodology, back in days in the 2022, I have used an Arduino as a microcontroller, but right now we are going to move to the ESP32 because of, since we need to integrate machine learning as well as the artificial intelligence to provide a better accuracy output. We need an internet facility and we need a microcontroller which is going to handle the ML and AI process. That's why we are moving to the ESP32. And also from the documents or else from the citations papers I have taken, they have also used the ESP32, which have several advantages over the Arduino module. I will provide the difference between Arduino module and ESP32 in a technical part in the next slide. So stay tuned. Right now, let's explore the microcontroller we are going to use. The processor GLUFI is what they have said here. Paper in GLUFI prototype, a non-invasive glucose meter based on near-infrared NIR spectroscopy. Verdict: high suitable, immediate implementation. Why it fits? This paper is the most practical guide for your electronics engineering background. Yeah, okay, good. Key upgrade for you, microcontroller. It confirms ESP32 is a perfect choice, better than Arduino for AI and connectivity process. Yes, ESP32 has built-in Wi-Fi module compared to the Arduino, which doesn't have. And also, most important here, they are saying as a secret sauce. Okay, what it is? ADS 1115, a 6-bit ADC. Your previous hackathon, yes, I have in the previous hackathon, I have used the Arduino Uno, which has, I think, a 10-bit, which is 1024 steps. But this ADS 1115 has 16-bit, 65,536 steps. But this ADS 1115 is an extra module we are going to combine with the ESP32 microcontroller. Your previous hackathon project likely used Arduino inbuilt because of it is an inbuilt one. Yes, Arduino have the inbuilt ADC, which is analog to digital converter, inbuilt present inside the Arduino itself. But here, ESP32, we are going to use a microcontroller for the connectivity purpose and AML purposes. We are going for the separate ADC, analog to digital converter, which is nothing but ADS 1115. Let's search for this ADS 1115. So some short, these are the equipments we are going to use too. Okay, this also comes with the handy of plenty of 125 rupees, easy to manage in an economic way. So guys, since this we are going to make it as a prototype and we are going to, for the product, first we need to make this entire equipment in an economic way. This is a very much important one. That's why I'm saying the cost. Okay, looks good. This is an ADS 1115 16-bit ADC 4 channel. Yes, this is what we are looking for. Good. So this is going to be combined with the ESP32 module. So what happens, what it helps, because allows you to see the tiny changes glucose cause in the signal. Yes. Okay, good. I understand this one. You can see the latest pass, we got that analog signals and we are going to convert these analog signals into a digital signal by using this ADS 1115. Previously, we used Arduino, which has inbuilt 10-bit ADC, not efficient because it cannot produce a slight change. Major change happens in the light rays, it will produce an output. But if you use this ADS 1115, we can eventually measure each and every tiny causes. That's what they are saying. They are trying to say here. This is what the Gemini trying to say. Allows you to see the tiny changes glucose causes in the signal. Yes, super. Okay, which will eventually increase the accuracy, or else if you're going to feed the data into the machine learning, will help us to calculate the data in more accurate manner. Okay, good. Noise filtering. It uses silent key active low pass filter. I don't know about this silent key low pass filter, but I need to, I think I need to make a different circuit for this low pass filter for the noise cancellation. I think so. Yeah. The silent key active low pass filter is a different circuit method or circuit methodology apart from this ADS 1115 and AES-32 for the noise cancellation process. Okay. Circuit to remove 50 to 60 hertz mains hum and high frequency noise before the signal ever hits the processor. Okay. Which it's I think for this first we got the, let me draw this one simpler manner. I will draw this one. Yeah, I can understand this one. This compartment entirely belongs to the sensing unit. Entirely belong to the sensing unit. Understand? This is entirely belongs to the sensing unit. Next, let us consider this entire box as a sensor. Next, this sensor is going to provide output as a wave format, which we called as analog waves. What this is? I will draw itself. Okay. Which will eventually called as analog waves. This is called as analog wave. This is an analog wave, but sensor can't easily understand the analog wave. What we need to do, we need to convert these analog waves into digital waves for the better output, and needs to analyze even the tiny changes. For this purpose, we are using ADS 1115 as a part, and this ADS is going to provide bits type of output, which is the digital output. We are going to pass this digital output via this Allen key active low pass filter. Now I hope you people understand what we are trying to get. Yes, this output will eventually passed to the silent key low pass filter. Okay, so next we will reduce some noise and we are going to provide the digital output to the microcontroller, which is nothing but ESP8266. ESP, sorry, 8266. Sorry guys, this is the device I have used the some other projects. That's why in a fluent manner I have said this. ESP32, sorry. ESP32. So this is an entire flow diagram of that. This is a sensor. This entire blue compartment is a sensor. But this sensor is a fabricated one. Understand? We need to fabricate this first process. Second, this sensor is going to provide an analog signal which we are going to convert this by using an ADS 11115. Sorry, I have mentioned 115. Next, this is going to provide some signals which eventually pass through a silent key active low pass filter circuit, and this circuit provide a digital signal which reduces some noise from the analog signal, and we are going to pass this to ESP32. First, we need to search for this silent key active low pass filter. If I got the okay, I got the circuit. Super cool. Silent key. But before drawing this one, we have resistor, we have capacitors, and we have voltage output. We need to entirely fabricate this circuit too. This silent key active low pass filter. 50 hertz and 60 hertz main. Okay. Next, as I have said, what we need to do, we need to pass this to the ESP32. Next, for processing of the data, a data processing paper. Here, what the Gemini have told. Although this paper uses microwave sensor CSRR, the machine learning pipeline is exactly what you need for optical sensors too. Yeah. So CSRR, they have used the microwave sensors, but because of, you can see in the image itself, this passing a microwaves. The selenium, what germanium selenide. Okay, I forgot the name. Sorry, germanium selenide, which is going to pass a microwave instead of the optical waves. But in our condition, we are passing the optical wave. So what we are going to do is that we are going to fetch those calculated data. ESP32 is going to provide the calculated data. Here we are going to provide the output in a two different manner. One is going to represent the glucose module, and another one is going to collect the data, and we are going to train the model. Do not feed raw voltage into array. Yes, we are not going to do. The paper proves that future extraction is the key. Use discrete wavelet transform DW2 to clean the signal and separate noise from the glucose data. Okay, good. The model, instead of deep learning, which needs huge data. Yes, this paper achieved 80% accuracy using XGBoost and light GBM. These models are lightweight enough to run on your Raspberry Pi or ESP32. Good. We are going to use these two models, XGBoost and light BGM, which provides 80% of accuracy. Good. The deep learning paper, what they have said, maximizing glucose reduction accuracy. This paper discussed speckle patterns using lasers, but the text is quite mixed and theoretical. It mentions complex architecture like Medusa attention block or encoder decoder, which might be overkill for the side hustle prototype unless you have those thousands of images. We are going to provide thousands of images. Okay, this is the patterned table. For the sensor, we are going to use 940 nanometer, which is we used in the previous one. Here we are going to use 650 nanometer of red laser. Okay. Okay. So here you can see this is the laser part, which is a light emitting diode. Needs to be a. This is going to be a 650 nanometer of red laser. So particularly, I need to search for the 650 nanometer red laser online. I will check through that too. This is a red 650 nanometer red laser. This laser light is going to be passed through the polarized sheet, and that rays will be eventually pass our sample, and that and the remaining rays will be eventually pass the 90 degrees rotated polarized light, and eventually the photo day. Okay. Source paper, in the source paper they have said germanium selenide they have provided in the source paper, but these are the fabricated one. I think I don't want to go with a higher cost. I stick to the lower economic cost. That's why I have the Gemini has provided 650 nanometer red laser and polarizers. Next, what they have done For the analog to digital converter, previously we have used inbuilt Arduino ADC, but here we are going to use ADS 1115 16-bit converter, which is also referenced in the GluFi paper, reference paper that we have taken here. You can see GluFi paper. And the processor, we are going, in the previous methodology we have used Arduino UNO, but here we are going to use ESP32 for the connectivity and also for the A and ML purposes, which is also mentioned in the GluFi paper. For the circuit direct connection, which is we are going to use a Salon key low pass filter hardware denoising, but in the previous methodology we don't use that. We have directly connected some equipments, that's why. But in now we are going to pass it with a Salon key low pass filter for the hardware denoising. Next, for the AA model, we are going to use XG boost and classifier. And the pre-processing, we are going to discrete wavelet transform. So this is a table. I hope you guys have understand what is we are going to do with this R&D process. In upcoming live video, I will share the thought. If you are interested, you can also combine in this live, or else you can also combine in upcoming lives. If you are an electronic person and if you want to learn something new, you can combine with me. If you want to combine with me, please check out my Gmail and contact it over there. And I hope I can and I will travel along with you in this R&D process. Until then, we will catch up in the next live. Thanks for watching. Thank you.